Hi, everyone. On behalf of IAUG, I would like to welcome you to today's webinar, Avaya Aura Session Manager Adaptation, Manipulating SIP Messages in Wondrous Ways, presented by Avaya and sponsored by DTS Analytics. Thank you for participating in today's webinar and for your continued support in the IAUG webinar program. Before we begin, I do have 3 quick housekeeping items to go over. First, today's webinar will be recorded and available for on-demand viewing in our IAUG member webinar library. Second, a Q&A session will follow today's presentation. All questions will need to be entered in the question window near the bottom of your GoToWebinar screen. Please submit your questions at any time throughout the presentation. And third, there will be a short evaluation that pops up as you exit the webinar. Please make sure to take a minute and let us know what you thought of today's session and what you might like to see going forward. Now, before we hand things off to Avaya, we have a brief message from our sponsor, DTS Analytics.
Hello, everyone. My name's Kate Fetchick from DTS Analytics. DTS Analytics designs, develops, and delivers a robust set of workforce optimization solutions for enterprises of various sizes, with particular strength in government, financial, healthcare, retail verticals, and BPO contact centers. We have over 3 decades of experience in the workforce optimization space. This is an enterprise-grade product. The product is agnostic, so we're highly interoperable with the most popular UC, UCaaS, and CRM platforms out there. And just a side note, we do have a native integration with Salesforce out of the box. You can procure our product from 3 different perspectives: cloud, on-premise, or subscription. The Encore Workforce Optimization is a suite that we sell. This suite of products can be actually purchased all at once, or you can start out here on the left-hand side and move seamlessly and integrate as you grow. So you can start out with our interaction recording, which includes screen recording, as well as we do have an option for desktop recording. We offer interaction analytics, which are call analytics, desktop analytics, survey analytics, and speech analytics, featuring PCI, automatic redaction, and automated quality coaching. We also offer our performance management, which is our traditional quality management. These are tools designed to measure and help improve agent performance. We also offer, last but not least, workforce management, which provides staffing forecasting, scheduling, real-time adherence tools, so that you can see where your people are they where they're supposed to be, when they're supposed to be there, doing what they're supposed to be doing. We have been an Avaya DevConnect partner for many, many years. We also keep up with the latest and greatest releases of the Avaya products, and we are currently up to date on testing and certification of Avaya products. So check us out on the web at dvsanalytics.com and let us show you how we can enhance your Avaya contact center. Thank you.
Thank you, Kate. Now let's get started. I would now like to turn things over to Dennis Sanger from Avaya.
Hi, this is Dennis Sanger. I'm a consulting engineer with Avaya. I've been working on Avaya's telecom product and Avaya's predecessor companies, AT&T, Bell Labs, and Lucent for the past 35 years. Products like Communication Manager, and I've been part of the Session Manager team since day one, about 10 years ago, I guess, or 12 years maybe. And today I'm going to talk about one of the bigger Session Manager features, that's adaptation. So a quick overview of what I'm going to talk about. First of all, let's define adaptation. What is it? And then we'll walk through the various flavors of adaptation. There's the classic flavor of adaptation, that's digit adaptation. There's some wrinkles you may not be aware of. There's some fairly cryptic parameters you can set. There are also vendor-specific adaptations. There's an option to create your own adaptation, custom adaptation. And finally, there's endpoint adaptation. That's a feature that's been fairly well hidden for many years, and we recently exposed it. A couple of years ago, we did major development on adaptation, so we've got some new adaptation features that are fairly recent. There's regular expression adaptation that applies mainly to SIP entities. And then we've combined endpoint adaptation with regular expression adaptation to come up with something called device mapping. Finally, I'll talk a little bit about troubleshooting tools. The 2 that are most relevant for you here are the call routing test and the regular expression tester. So let's dive in. What is adaptation? So here's a collection of definitions. First of all, broadly speaking, adaptation is just the modification of SIP messages as they enter Session Manager and as they leave Session Manager. Modifying messages as they enter Session Manager we refer to as ingress adaptation, and modifying messages on the way out is what we call egress adaptation, just fancy terms for in and out, really. Digit adaptation is sort of the classic version of adaptation. It's what we've had since the beginning. It's the ability to manipulate digit strings as SIP invite requests come into Session Manager and as they leave. It's the same sort of thing that you were able to do with Communication Manager for the past 30 or so years. Why would you want to do this? It's to convert between different dial plans. Maybe you have different dial plans in different parts of your enterprise, or you're converting between your private dial plan inside the enterprise and an E164 dial plan in the public network. We soon discovered that people want to manipulate SIP messages in more ways than just manipulating digit strings. Specifically, what we discovered was that various vendors have slightly varying interpretations of the SIP standard. And one of the big selling points of Session Manager is that you can help various vendors' equipment communicate with each other, even with these varying SIP dialects, by using a vendor adaptation. Similarly, various vendors' SIP endpoints speak slightly different dialects, and you can account for that as well with endpoint adaptation. Next, we added custom adaptations. So what we discovered was that certain customers had very specific needs for adaptations that we hadn't built yet. And they maybe weren't general purpose enough to introduce them as a new, generally available kind of adaptation. So there is a capability to drop in some Java code to create your own adaptation. The vision was that customers could write their own, drop them in. That never quite came to fruition. Instead, you can pay Avaya professional services to write an adaptation for you. And then we get to the big new developments of the past few years. There's regular expression adaptation. So rather than just manipulating digit strings or just making these specific vendor-specific tweaks to the SIP dialect, now we're going to let you manipulate SIP messages in pretty much any way you want to. So that's regular expression adaptation. And then finally, the most recent new feature, device mapping. And that's pretty much just endpoint adaptation meets regular expression adaptation. So let's talk about digit adaptation for a little bit. This is the classic version of adaptation. It lets you modify digit strings in the SIP messages. So for example, in the request URI, in the to and from headers, there are a few other headers you can modify as well. You match on a digit pattern, and this is very similar to what Communication Manager does. You match on a digit pattern, so you're matching on the leading digits. You're specifying a minimum and maximum number of digits for the digit string. And if you have a match, then you can insert and delete digits. Again, you can do this on ingress to SM or on egress from SM. So for example, you can convert from your internal dial plan. Maybe you have a 7-digit dial plan. Then when you go to your service provider, you want to convert to E164 numbering. After you create an adaptation, then you apply it to one or more SIP entities on the SIP entity form. So let's take a look at what those forms look like. Here's the adaptation form. So you give your adaptation a name. You have to choose a module. The most basic module is going to be the digit conversion adapter. It does nothing beyond digit conversion. We'll look at the other modules in a little bit. Something new that you may not have seen before is the state field. So you can now enable and disable adaptations. So suppose you spent a lot of time crafting an adaptation, getting it just right, and then you discover that there's some tragic flaw in it and calls are failing. Well, rather than delete the thing and have to rebuild it later, you can just disable it. It no longer takes effect, and then you can take your time and figure out what went wrong. Module parameters, I'll talk more about this in a few slides. But for now, the most common, the most popular module parameter is the from-to parameter. If you set that to true, then the from and to headers are also going to be adapted in addition to the request URI. And then we get down to the actual digit manipulation. So you've got two sections here. There's digit conversion for incoming calls, and there's digit conversion for outgoing calls. And in each of those sections, you're going to enter your pattern, minimum, maximum digits, and then the action you want to take when you match that pattern. So the example I've got here for incoming calls, if I see a digit string that starts with +1 303 777, and that digit string has at least 12 digits and at most 12 digits, so exactly 12 digits, then what I want to do is I want to delete the first 8 digits and then insert a digit 5. Address to modify, that can be origination or destination. I'll talk more about that on the next slide. And of course, the other option is both. So let's talk a little more in detail about the various fields. Matching pattern, those are the leading digits you want to match. It can include a plus, star, or pound as the first digit, only the first digit. You can also include an X anywhere as a wildcard to match one digit. You can use multiple X's if you want. The wildcard isn't really all that popular. I mean, an application you could imagine, you want to match leading digits 303, XXX, 555. So those X's can be any digit. If you match that, then you'll insert and delete digits however you want. Minimum and maximum. That's not necessarily that interesting in North America, where we have a fixed number of digits in the public network. But in the rest of the world, where you can have variable numbers of digits in your dial plan, you specify you need to see at least this number of digits, at most this number of digits, in order for this to be a match. So if you do match, then there are two actions you can take. One is to delete some digits from the front of the digit string. What you specify is how many digits you want to delete. You can also insert some digits in the beginning of the digit string. You specify the digits you want to insert. Back to address to modify. So you can modify either origination headers or destination headers, or both. Origination would be headers like from, p-asserted identity, history info. Destination is the request URI or the to header. Then the next step is to assign your adaptation to one or more SIP entities. Here's a new wrinkle. As of SM801, you can add multiple adaptations to each entity. So you can modularize your adaptations and then combine them in various ways. The thing to remember here is that these adaptations will be applied in the order that you have them in this list. You see there's an order field with up and down arrows. You can move the adaptations up and down. Order may matter. The adaptations will be applied in this order, and if you do a digit string modification and then you may modify that digit string again after the modification if that's what happens in one of the later adaptations. My recommendation is that you make sure that your adaptations are totally independent so that order doesn't matter at all. Adaptation module parameters, I mentioned this a few slides ago. What we discovered is that in addition to modifying digit strings, people want to make other tweaks, and there were various little tweaks. Back when you could only assign one adaptation to a SIP entity, there really wasn't any other way to do these additional tweaks. You had your digit conversion adapter, and you couldn't apply other adaptations to that particular SIP entity. So the solution was to add various parameters. Unfortunately, this is a fairly cryptic way to do this. There are a lot of different parameters you can set. So the example I've got here is the from to, which is probably the most popular parameter. If you set that to true, you're going to modify the from and to headers in addition to the request URI. The next one, IO source D, that's going to modify the domain. So let me show you some of the more common parameters. I talked about from 2 already. IO dest D is the abbreviation for ingress override destination domain. You can actually enter either of these, although I don't know anybody who puts in the longer version. So what that does is replace the domain in an incoming SIP request with whatever value you enter there. There are other similar parameters that do the same thing for egress, for destination domains, for source domains. Other parameters, there's IR headers and ER headers. Those remove the specified headers on ingress or egress. So if there are certain headers that the destination SIP entity just can't handle, you can remove those using this parameter. You'll see later in this presentation that you can do this in a much less cryptic way using regular expression adaptation. Finally, there's the no AR parameter, and this is a peculiar case. Here you're not actually modifying the SIP message. Instead, you can prevent alternate routing when you receive a specific response code. So for example, you send an invite to a SIP entity and you get back a 408 response. That would normally cause alternate routing. If for some reason you don't want to alternate route when you get a 408 response, then you could set this no AR parameter, specify 408, and that will prevent alternate routing. It's not a very obvious way to get this functionality, but you know, there it is. I would refer you to the documentation. There are other parameters with yet more specific behaviors. You'll also find more details on these particular parameters. So back to our example. So imagine you have an invite with an E164 number in the request URI, so +1 303 777 7777. The from header has an E164 number as well, as does the to header. So you apply the example adaptation. What that was going to do is, if it matched these leading digits, it was going to delete 8 digits, and the plus counts as a digit in this case, and replace it with a 5. So that's what you see inside of the Session Manager box. And you can do the same sort of adaptation after Session Manager figures out which SIP entity you want to route this invite to. That would be egress adaptation. So as part of ingress adaptation, the adaptation is going to be reversed for responses. So this 180 ringing response that comes back in the reverse direction, the ingress adaptation is going to be undone. So the short number is going to be turned back into the long number. So don't confuse this with egress adaptation. The adaptation of the response is still ingress adaptation. It's just ingress adaptation for a response in the reverse direction. Let's talk about vendor adaptations. So this is a layer we put on top of the digit adaptation. So in addition to the very basic digit conversion adapter, we've got several vendor-specific adapters. So if you're talking to a service provider that speaks a slightly different dialect of SIP, these adaptations will take care of that for you. Some examples here. The AT&T adapter removes history infos on egress. The Cisco adapter converts remote party ID headers to p-asserted identity and vice versa. So depending on which service provider you're trying to talk to, we may have an adaptation for that. Now, these vendor adaptations could just as well be implemented with regular expression adaptation now. So if you come up against a service provider that's not on our list of adaptations, you can probably build your own regular expression adaptation to take care of whatever dialect differences there are. Custom adaptations, I mentioned earlier that you could write your own adaptation and just drop some Java software into your session manager, and now you've got an extra adaptation. We had this notion that customers would be able to build their own, but really it's a fairly complex process, and we never felt quite comfortable that we had it well documented enough to make this really a viable process. So in practice, what customers do is they go to Avaya Professional Services, and then Professional Services can build you a custom adaptation. There's some wrinkles with custom adaptations. For example, after every session manager upgrade, you're going to have to reinstall the custom adaptation, which is a little unfortunate. Theoretically, we've made custom adaptations obsolete with the introduction of regular expression adaptations. So now you can build your own adaptations without needing new software. Endpoint adaptations, this is similar to vendor adaptations. So various SIP endpoints from third-party vendors, again, have slightly different dialects of SIP. And to compensate for that, Session Manager tweaks outgoing invites or incoming invites as needed to account for that. For the longest time, endpoint adaptations were hidden under the covers. They weren't documented. There was no administration needed or possible. So some examples of endpoint adaptations. Cisco endpoints have a limit on message size. They hate large messages, and sometimes SIP messages can get very large depending on how often they bounce around your network. Also, Cisco endpoints require accept headers. So this was all taken care of under the covers for you. Same thing for Polycom endpoints. They hate contact parameters that start with plus. Session Manager takes care of that. And the most recent one, Celta endpoints, again, hate large messages. They just won't accept invite requests that are above a certain size. Session Manager takes care of that for you. And all of this was hidden from you. There was nothing you had to do to get this functionality, and there was really no way you could change this functionality. As of SM812, the new device mapping feature actually lets you build your own endpoint adaptations. I'll get to that toward the end of this presentation. And that brings us to regular expression adaptation, a new feature as of SM801. This takes adaptation into a whole new realm. With regular expression adaptation, you can modify pretty much any part of a SIP message using regular expressions. There's a handful of parts of SIP messages that you're just not allowed to modify, like, for example, the SIP method. You can't turn an invite request into an options request, for example. But you can do pretty much anything to the message other than that handful of things that just aren't allowed. Various URIs inside the SIP request can be changed by doing things far beyond inserting and deleting digits. You can insert, delete, or modify pretty much any SIP header to accommodate those third-party SIP dialect quirks I've been talking about. You don't have to wait for Avaya to create a new vendor adaptation for that. You can create your own depending on your needs. The first thing you have to do is enable the feature on the global settings form. And then you dive into a collection of forms to create your regular expression adaptation. So here's a description. Well, first of all, let's talk about regular expressions. I obviously don't have time to do a full regular expression tutorial here, and honestly, that's not even productive because there are many, many regular expression tutorials on the internet. My observation is that you could spend a week learning about regular expressions and still not be done, but in practice, 99% of what you're going to do, you can figure out really within a few minutes. So I'm going to give you like the 2-minute overview, and that should be enough to get you through the rest of this talk with no problem. So first of all, what is a regular expression? It's a sequence of characters that you're going to use to try to match a string. And that sequence of characters contains either regular characters, so upper or lowercase letters, numbers, punctuation, and it contains optionally meta characters, so a wildcard or quantifiers. And like I said, 99% of the regular expressions you're going to run into will consist of regular characters and just 4 meta characters: the dot, the question mark, the plus, and the star. So the dot is the wildcard. It matches any character. And the other 3 are quantifiers. So a question mark means 0 or 1 of the preceding character. A plus is 1 or more of the preceding character. A star is 0 or more of the preceding character. If you want to use one of those characters as just a regular character, like you really want to match a plus or a star, both of which are common in SIP, then put a backslash in front of it. So a couple of simple examples here. So the regular expression A3 semicolon C matches only A3 semicolon C. There are no meta characters in that, so it matches exactly that string. And a lot of what you're going to use in regular expression adaptation is just going to be regular characters matching exactly some string. You may never need to use meta characters. Next example, A dot star F matches, for example, AF, or it also matches A5F. It matches A2B pound F, among many, many other, in fact, an infinite number of other possibilities. Third example, SIP S question mark. So that question mark means 0 or 1 of the preceding character. The preceding character is the S. So this regular expression is going to match only SIP or SIP S. Final example, backslash plus A backslash dot B. Those backslashes escape the meta characters, so they're no longer meta characters, they're actually regular characters. This is going to match only plus A dot B. And again, there's lots more information about regular expressions on the internet, but I don't think you really have to be an expert on regular expressions to get something out of the regular expression adaptation feature. So let's go through the process of regular expression adaptation. Each regular expression adaptation is going to have a list of ingress rules and egress rules, similar to digit adaptation in that respect. So you can modify SIP messages either coming into Session Manager or before they leave Session Manager. Each rule has a regular expression condition that determines whether that rule is going to be applied to the message. I'll show you more detail about the conditions. It's just an incredibly powerful feature that determines whether this adaptation is even going to happen. Each rule can also have variables that you set based on regular expression matching against a part of the SIP message. So these variables will allow you to, for example, grab the contents of one header and shove it into a different header. We'll see examples of that later. Each rule has a list of actions that are going to be performed on the message if the condition passes. And the actions fall into 3 categories. You can add something to the message, you can modify an existing part of the message, or you can delete a part of the message. And these actions can use those variables that you've set. Let's take a look at the relevant forms. So let's start with the adaptation form. There's a separate regular expression adaptation form. This is different than digit adaptation. There's not a whole lot on this particular form. You give it a name, there's the state, you can enable and disable. And then you've got your incoming rules and your outgoing rules. If you click on a rule, it takes you to the rule details. And each rule has a name. You can add a condition. I'll show you an example of a condition in a second here. You can administer conditions. You build yourself a condition and then choose it here from the dropdown. The direction is either incoming or outgoing, and order matters. And I mentioned earlier that you can have multiple adaptations for a SIP entity now. You can also have multiple rules within a regular expression adaptation, and the order of the rules matters. And again, I encourage you to write your rules such that they're independent. So each rule fiddles with a different part of the SIP message. The rules don't interfere with each other. If you design your rules to be independent, then ordering won't matter. If your rules fiddle with the same parts of the message, then order will definitely matter, and you may find yourself with some unexpected behaviors depending on which order you put your rules in. So a best practice would be to make sure that your rules are independent. We've got the rule variable section there. You give your variable a name, and you specify what you want to put in that variable. And there are 4 things you need to specify here. There's a source type, source, instance, and match expression. The source type is what part of the SIP message do you want to modify? or add, delete, modify? Do you want to mess with a header, an attachment, the request line, the response line? The source then would specify more specifically out of that source type exactly what part do you want to modify. Most commonly, I think you're going to modify headers. So the source, if you pick source type header, then the source would be the header name that you want to modify. So this example here, you want to modify you want to populate this variable from the alternate CLI header. Instance specifies, well, which instance of that header you want to modify. There are some SIP headers where you can have multiple instances, route headers, for example, or via headers or record route headers. So the instance you can specify as an integer, so 1, 2, 3, 4. Also, you can make it negative, and then you count from the bottom. Top and bottom are synonyms for 1 and -1. And there's some other possibilities for instance that I'll show you later. The match expression is a regular expression, and this is where you specify what part of that header you want to extract and put in the variable. So whatever is inside the parentheses is what's going to be captured into that variable. This here is the most basic possible example. So inside the parentheses, you've got dot star. Recall that dot is a wildcard and star means 0 or more of those. So basically dot star is going to capture anything. So it's going to capture the entire header. The parentheses mean take that entire header and stuff it in this variable. Then we get to the rule actions. You've got add, delete, modify as possibilities for the operation. Source type and source work the same way as for the variables. So in this case, I'm specifying the alternate CLI header. Instance is similar to what it was in the case of the variables, but you've got some other possibilities here. In this example, I'm saying any instance, which means if I have multiple alternate CLI headers, all of them will be deleted. The operation is delete in this case. The match expression, that has to match in order for the operation to occur. So what I have here is dot star, which is going to match anything. So any alternate CLI header will be deleted by this particular action. There's a second action here. I want to modify the p-asserted identity header. So for a modify, you've got a match expression and then a replace expression. And these regular expressions are getting a little more complicated. This particular example is fairly involved. So I don't need to get into details necessarily, but let me point out some interesting features of this here. So what I'm doing here is the dot star again means anything. So anything inside double quotes will match. And then I want to match SIP-S question mark. So recall from the example before, SIP-S question mark will match SIP or SIP-S, colon, then dot star and an @ So everything before the @ is the user portion of the URI. So if that matches, then I want to replace it. And in the replace expression, you'll see dollar, curly bracket, alternate CLI, curly bracket. That's going to take what I put in that rule variable, the alternate CLI variable, and stuff it into this header. And you'll see that that occurs twice in that replace expression there. So you can use variables multiple times. The $1, that's another variable, but in this case, $1 means the first captured variable from the match expression. So in the match expression, you see some parentheses there. What's inside the parentheses, that gets stuck in $1. So the numbered variables you can only use inside that one particular action. The numbered variables don't span actions. The named variables, the ones from the rule variables section, you can use those in any actions, but only within this one rule. Let's look at regular expression conditions. So a condition is a tree of regular expressions applied to whatever parts of SIP messages you specify, connected by ands and ors. You don't have to make it a tree. Your condition can be very simple, but if you want, you can build yourself a wildly elaborate condition. Again, the regular expression operand has source type, source, instance, and regular expression like we just saw. The source type is request line, response line, header, or attachment. The instance is going to be positive, negative integer, or any, or all. So let's look at an example. Here's a fairly straightforward example. So this condition that I called wealth management, what that's looking for is an alternate CLI header. So if any of your alternate CLI headers match wealth management, and here's another little wrinkle in the expression. If you have something inside square brackets, that means one of these characters. So here we have square bracket capital W, lowercase w. That means either a capital W or a lowercase w. Same thing for management. Another regular expression wrinkle here, inside parentheses is management spelled out, then a pipe symbol, and management abbreviated as MGMT. So it means either management spelled out or management abbreviated as MGMT. These are some of the more advanced regular expression features, but the bottom line is, if the alternate CLI header contains the string wealth management, then this condition applies and the adaptation rule will be applied. If you specify a logical operator, so an AND or an OR, then you can add a second operand and check a different header or the request URI or whatever part of the SIP message you want. If you're using an AND, then both operands have to be true. If you're using an OR, then one operand has to be true. The source type can be condition, in which case the source will be a different condition. So that would be how you can build yourself a tree of conditions. So I could have condition A that is condition B or condition C, and then condition B can be condition D and condition E. Condition C could be condition F and condition G. You can see how you could build yourself an elaborate tree of conditions that way. Variables, we already talked about most of this. Let's see if there's anything else I need to talk about here. So back to the instances, positive and negative integers. So one would mean the first of that header. I didn't really dwell on this, but in addition to modifying SIP headers, you can also modify SIP attachments. The most common kind of SIP attachment would be SDP, so specifying media. You can also have XML attachments, all depending on your application. But you are allowed to modify those attachments using regular expression adaptation. So one would mean the first header or attachment. -1 would mean the last one. Top and bottom are aliases for those. First match would mean the first matching header. Last match would mean the last matching header. So if you have a bunch of route headers that you're trying to match, for example, first match would be the first one that matches my regular expression. If multiple ones match, I'm going to use the first one. Last match is what it sounds like. If multiples match, I'm going to use the last one. So yeah, we've talked about regular expression variables. Okay, examples of regular expression variables. We already looked at one example. Let's look at a couple other examples. So for example, I create a variable, I call it request URI user. So I want to match the request URI against the regular expression SIP-S question mark, colon, ** in parentheses, at avaya.com, and that dot is escaped with a backslash. So what's going to happen here is I'm going to take the piece before the at, the piece inside the parentheses, and capture it into the variable. So that's going to be the user part of the request URI. And again, the SIP-S question mark will match either SIP or SIP-S. And the dot in avaya.com is escaped with a backslash. If you forgot to escape it, it would still match avaya.com because the wildcard matches any character. But once in a long while, you might find yourself with an unexpected match. So avayaxcom.com, for example, might match. That would be not what you're expecting, but that's going to be a pretty rare case. But in any case, when you mean a literal dot, it's a good practice to escape it with a backslash. Another example, bottom via host. So you want to capture the bottom instance of the via header, and you want to match the regular expression SIP/2.0/\w+. \w means any word character, so letters or underscores. Plus means one or more. And then in parentheses, we've got \d plus. So the \d is any digit. So one or more digits, a literal dot, one or more digits, literal dot. The thing inside the parentheses is supposed to be an IP address. So what you're doing is you're capturing the IP address out of the VIA header. A note about regular expressions for IP addresses. What I have here is going to match all valid IP addresses. It's also going to match a large collection of invalid IP addresses. So \d plus matches one or more digits, so it would also match 999, for example, which is not a valid octet in an IP address. If you wanted to come up with a regular expression to match only valid IP addresses, that's a pretty fair science project. You'll find examples of that on the internet. They're very, very long regular expressions. It's probably not worth the effort. Last example, alternate CLI. I want to capture the top instance of the alternate CLI header if it matches **. Of course, ** is going to match anything. So that will capture the entire contents of the alternate CLI header. Let's talk a little bit about regular expression actions. So you can add, modify, or delete parts of a SIP message. As far as adding or deleting, you can only add or delete headers or attachments. You can also modify the request URI or the response code. I've already mentioned you specify what part of this message by specifying a source type, source, and instance. And then, yeah, I've already talked about instances. So for actions, there are a couple of other possible values for instance. For example, any, which means if I want to modify headers and I say, well, modify any route header, that means every route header I encounter, I'm going to modify. First match, last match, I already talked about. For an add action, you're going to add a new header or attachment. The instance that you specify there, that's the position at which you're going to insert this new header or attachment. So for example, if the instance is 1, then you're going to, suppose I'm adding a route header. Instance 1 means put that route header at the very top. Instance -1 would mean put it at the bottom. If you try to add an instance that doesn't exist, so for example, you have one route header and you say, okay, I want to add route header 5. That's obviously not going to work. So the adaptation won't happen. We've already talked about the named variables, and here's an example. So yeah, you add a top route header. You can use a variable inside that, so $IP address. You pull the IP address out of a different part of the SIP message, plop it in as a new route header. That's an example of an adaptation you could do. Delete actions do pretty much what you would expect. A couple examples here. Maybe you want to delete the top route header if it matches a specific IP address. And again, those dots in the IP address should be escaped, otherwise you may get some unexpected behavior. Modify actions, we've talked a bit about these. So you specify, for example, a specific header and you want to change the content of that header. I've already mentioned named and numbered variables. So here we have an example of a modification. So let's say I want to change the third route header. If it matches this specific IP address, the parens and ** in the middle, I'm just going to take whatever is in that route header, capture it into a variable because I want to reuse it, and I'm going to replace it with $address, so that's a named variable that was set somewhere in that rule. Semicolon $1, that's that piece that I captured inside the parentheses. I'm going to reuse whatever was there, and I'm changing the transport from TCP to TLS. So performance considerations. Obviously, this is different than digit adaptation. Digit adaptation is highly optimized for performance. There's very little CPU impact for digit adaptation. Regular expression adaptation can have performance impact. Just the act of doing a regular expression match is more expensive than digit matching. Unfortunately, I can't give you a cut and dried answer here. the performance impact is very, very configuration dependent. I can't say, for example, well, you only have one regular expression adaptation, so you're going to be fine. Or you have 100 regular expression adaptations, that's going to be a disaster. Neither of those is necessarily true. We've done some performance measurements using what we consider a typical usage of regular expression adaptation. And what we found is it increases CPU by about 5%. Relative to what it was before. So the impact is not huge if you're doing something that we would call typical. Now, unfortunately, I can't give you any sort of guidelines as to what typical means. Again, this is highly, highly configuration dependent. So what it comes down to is, try something, see what happens. The vast majority of things you try will not be disastrous. I will show you an example of something that is disastrous later. But really, the performance impact is, in general, in a typical case, not disastrous. It's pretty modest. Okay, the disastrous case, there's something called regular expression denial of service attacks. And this is not specific to what we're doing here, regular expression adaptation. This is a well-known class of denial of service attacks. So if you have a poorly considered regular expression and it's confronted with exactly the wrong SIP content, you can use a tremendous amount of CPU doing that regular expression match. And I can construct examples. They're very contrived examples. They're examples that you are extraordinarily unlikely to encounter in the wild. But I can construct an example that will bring down a session manager. It takes just 2 or 3 calls and your session manager is done processing calls. So how likely is this sort of attack? Well, first of all, it requires somebody to administer a regular expression adaptation on your system manager. So this requires access to your system manager. It requires very specific knowledge of what to do on your system manager. It's pretty unlikely that some random hacker is going to be able to do this. Second, you need to encounter exactly the wrong SIP message content. So somebody has to send you a SIP message with some very unlikely content. Just typical SIP traffic is not going to trigger this sort of thing. So the bottom line is you're very, very unlikely to accidentally cause this sort of problem. It would have to be a malicious administrator doing this sort of thing. So I guess the message there is treat your administrators well. There's lots more detail about regular expression denial of service attacks, about performance impact, and also just lots of examples of very elaborate regular expression adaptations in a white paper on the Avaya support site. You've got the link here. You don't have to scramble to write down this link. This presentation will be available to you later. So if you're interested in regular expression adaptation, I encourage you to check out this white paper. So now let's talk about device mappings. This is another regular expression-based type of adaptation that we've introduced in 8.1.2. It's really the same as the old hidden endpoint adaptation, but we've expanded it to use regular expressions. We've made it administrable. Before, like I told you, there was no admin possible. So the impetus for this was a couple of years ago, we encountered these Celta endpoints. Celta is an Italian telecom equipment manufacturer that apparently went out of business a few years ago, and we've got customers who have piles of Celta endpoints. And if they want to replace their infrastructure with Avaya, they want to be sure that those endpoints still work. Turns out those endpoints are very sensitive to SIP message size. They have a very small maximum size. So we had to develop an endpoint adapter for these Celta endpoints. Wouldn't it be cool if you could do that yourself when you run into a third-party endpoint that has some little SIP dialect quirk without waiting for Avaya to develop a new feature? So what you can do as of SM 8.1.2, you can create regular expression adaptations, and you can associate those adaptations with groups of endpoints or users. Now, you associate an adaptation with a group of endpoints based on the type of the endpoint. And the way we know the type of the endpoint is from the user agent header when that endpoint registers. So you can match a user agent header with a regular expression. Alternately, you can use an origination dial pattern set to specify a group of users. And I'll show you the origination dial pattern set form in a little bit here. So then when you have a match either against the user agent header or against a dial pattern set, you can give it a sequence of regular expression adaptations, just like the ones we've been looking at, and it'll apply only to those groups of endpoints or users. You can do all the things you would do with any regular expression adaptation. You do need to enable this feature in the global settings. This is available only if all your session managers have been upgraded to 8.1.2 or later. So what's a user agent header? Like I mentioned, when a SIP endpoint registers, the register request includes a user agent header. Most requests are going to include a user agent header, in fact. That user agent header is supposed to tell you what sort of equipment is sending the request. So if you get a register from an endpoint, it'll tell you what kind of phone it is. This example here, we're looking at an Avaya 1X desk phone. This user agent header is not an Avaya specific thing. It's defined in the RFC that defines the SIP standard. And in my experience, it looks to me like pretty much all SIP endpoints populate this thing. Back to the origination dial pattern set. So you can define a group of users this way. So this is not based on endpoint type, this is based on user extension. The dial pattern set was originally introduced to support source-based routing. We're leveraging this feature to also let you do endpoint adaptations. So the example here, I have a set called patient rooms. Turns out in this particular hospital, all the patient rooms have 5-digit extensions that start with 5, except then they expanded the hospital and now we've got a couple of extra rooms, probably like huge suites for big donors, that are 62004 through 62013. So we've defined our group of patient rooms, and that'll come up in the example I show you in a couple minutes. So a combination of user agent, regular expression, and origination dial pattern set is going to map to a sequence of regular expression adaptations. You can specify one or both of user agent and dial pattern set. So you don't have to specify both. You can, for example, have just a set of endpoints of a particular type, or you can have a group of users based on extension. If you want, you can specify both. And then you've got your sequence of adaptations. And again, order matters. Be careful about what order you put your adaptations in, or ideally make them independent. So those hidden endpoint adaptations that we've always had, those are now exposed. So you've got the Cisco device mapping, the Celta device mapping, 2 Polycom device mappings. Those have always been there, you just haven't been able to see them. Now you can see them, and if you wanted, you could modify them, you could delete them, whatever you'd like. There is one new option for endpoint adaptation, that's routing header reduction. That's actually one of the most popular applications for device adaptation. I've mentioned that there are lame third-party endpoints that can't handle these big, beautiful Avaya SIP messages. So you can use routing header reduction to remove extraneous vias and record routes. And those get restored in the reverse direction. And this is something that you actually can't do using regular expressions. Regular expression adaptation lets you modify messages, but you can't save variables to be reused on subsequent messages. Any variables you save apply only to that particular message. So this is another hidden device adaptation that we've exposed. Let me give you a real quick example of how you might use this. So suppose you've got a hospital that doesn't want patient phones to display the calling number for calls from doctors. You could create a new regular expression adaptation that anonymizes the from, contact, and p-asserted identity headers, and then apply that adaptation to a dial pattern set that's just the patient rooms. So we already looked at the dial pattern set. So all doctors extensions start with 7. So we've got this action we've got this set of actions that's going to modify the PAI, the contact, and the from. They're all going to be modified in the same way. So you're going to match double quotes with dot star inside. Dot star matches anything. Then SIP:7 followed by one or more digits and the @ So any extension starting with 7 is going to match this. You're going to replace that with anonymous in double quotes, and you're going to change the URI to SIP:anonymous @ So now anytime a doctor calls a patient room, what shows up on the display in the patient room is going to be anonymous. And then the final step is to create a device mapping. So you've got your dial pattern set patient rooms. You're not going to specify a user agent because you want to apply this to all endpoint types. You've got your sequence of adaptations. There's only one in the sequence. That's the anonymous adaptation we just looked at. And there you go. Okay, the final topic before we get to questions is troubleshooting tools. I'm not going to have time to go into these in great detail. I just want you to be aware that they exist so that if you find them interesting, you can look at the documentation, play around some. First is the call routing test. This has been around a long time, but we've enhanced it to make it more useful for testing out adaptations. This is a system manager page that lets you enter a bunch of parameters like calling and called party URIs. And what it does is it creates a fake invite, has Session Manager pretend to route that fake invite, and before Session Manager actually sends that invite somewhere, it just gathers up a lot of information about why it would route it the way it's routing it and displays it to you on System Manager. So let me show you what that looks like. So here's the input. Parameters like calling party IP address, because that matters in terms of location-based routing. Calling and called party URI, time of day matters. And the new part is what's in the red box. So you can specify SIP headers, and these will be inserted into the fake invite. The output then is a long list of routing decisions. So for example, I evaluated this condition and the various parts of this condition were true or false. In my example here, the condition turns out to be true, so the adaptation is going to happen. So you see it walking through the various actions in the adaptation. This is all very useful if you're troubleshooting a regular expression adaptation and you don't know why it's not doing what you expect it to do. At the bottom of the screen, it shows you the original invite, the modified invite, and the difference between the two. You've got 3 tabs there. So this lets you see the effect of the adaptation that was applied. So it's very useful for testing adaptations. One additional wrinkle, I showed you that adaptations now have a state, enabled or disabled. There's actually a third state, test only. If you set it to test only, then that adaptation will only be used for the call routing test. So this lets you tinker with adaptations before putting them into production. You can run the call routing test, see the effect of the adaptation, and when it does what you want it to do, then you change it from test only to enabled. The other tool, the regular expression debugger, regular expressions can be complicated. So it would be nice to be able to see whether your regular expression actually matches the sorts of things you expect it to match. And you'll find plenty of regular expression testers on the web, but those are basically match or no match. They don't give you any more information than that. What would be better would be a regular expression debugger, which gives you feedback about how and why the expressions match. So System Manager now provides such a thing as of 8.1.1. You access it by clicking on that little icon on the match expression, and then it pops up an additional window that looks like this. And I'm not going to go into a great amount of detail about what this does, but in the top box, you put in your regular expression. The next box, you put in the text you want to match, and the output, after you click on test, it'll tell you whether it matched. It'll also tell you where it had to backtrack. The way regular expression matching works is it chugs through your input text until it finds something that doesn't match, and then if you have wildcards in your regular expression, it backs up a bit, tries a different path, until it finally either finds something that matches or until it exhausts all the possible paths. So the interesting information here is It tells you the near matches, where you came close to matching, but not quite, which can help you in debugging your regular expression. It also tells you how often you had to backtrack, which tells you what sort of performance impact you had here. And here's that regular expression denial of service attack. So this is a regular expression that you will likely never see in the real world. And the text that you're matching is also something you're not going to see in a SIP message. This backtracked 100,000 times before it bailed out and said, yeah, no, you don't want to do this. So here's an example of that regular expression denial of service attack. Again, I refer you to the white paper if you want more information about this. And that brings us to questions. Let me take a look at the questions. I'll answer questions for a few minutes here. We can go a little bit over past the beginning of the hour. I'm having a little trouble seeing the questions. Can the presentation be sent out? Marlia, I'm only seeing one question. Are you seeing more than one?
Hi, Dennis. Yeah, if you click the button on the right-hand side, it says undock pane. You can see them better.
Okay. Let me try that. I'm not seeing the undock pane button.
Okay, it's the it has a square and then an arrow through it.
Ah, that, okay.
Yeah, there you go. And then it opens up and you can see them better. You got a lot of great questions in there.
Oh, I'm sorry, that was the the hide control panel button. That is not the one I want. So as far as the questions go, I will answer all the questions, or at least the ones that are answerable, in writing. That'll be distributed to all the attendees within, say, a week. Let's see if I can find some questions to answer right now. Does look like quite a few. So I don't mind going 10 or 15 minutes over to answer a few of these. Will the presentation be sent out? I assume the answer to that is yes.
Yes, the presentation will be sent out.
Okay, when we tried to turn on regular expression adaptations, it seems to have disabled our normal digit adaptations. You know, I've heard about that. That is a bug. The workaround for that is to do a restart on the session manager, and we are working on a fix for that bug. That's a very uncommon bug. There are very few people who've encountered that, so this is not something that most people are going to encounter. Next question. And again, I'm not going to be able to answer all questions right here, right now, but I will try to provide written answers to these. Are there any plans to allow device adaptations to affect register messages? Unfortunately, that's not an easy thing to do, because the way device adaptation works is it keys off the user agent header in the register request. So when the register request comes in, we look at the user agent header to determine whether we're going to do adaptation, but you know, we're not going to adapt before we check that. So it's something we're considering, but it's a bit of a tricky topic. Let's see what else. Aside from the reference document, are there any documents that give examples of regex adaptations? There aren't really any examples in the regular documentation. The white paper is definitely your best source for some very elaborate examples. An example of an expression that will match either +1911 or +911. Yeah, so that's not a particularly complicated case. So recall that question mark will match 0 or 1 of a character. So if you want +1911 with or without that leading one, the regular expression that it corresponds to would be +1 question 911. And that plus, you probably want that plus escaped. So put a backslash in front of it. So not an overly complicated example there. Does enabling regular expressions require a server restart? No, absolutely not. Let's look at another one. Does that include record routes? So I'm guessing the question here is, can you modify record routes with regular expression adaptation? The answer is yes, you can. Further answer is that is quite possibly a bad idea. I mean, it depends. So I talked about route header reduction as a possibility for adaptation. And route header reduction is a special case of adaptation where it will take out record routes and then it'll reinsert them on the way back. So you won't break functionality. If you just do a regular expression adaptation and delete some record routes, you may find that in-dialog requests are not going to work correctly. If you use the route header reduction adaptation, that will reinsert those record routes in the opposite direction so that everything continues to work the way you expect, but you don't see all those record routes on the other side of the adaptation. So let's continue here. Here's a question about 4-digit dialing to 5-digit dialing. So could you dial 4 digits and Session Manager converts it to 5? Absolutely, that's what adaptation is for. So it depends on what you're talking about here. If you're talking about adapting invite requests from an endpoint and changing the digit string, I suppose in theory you could do that, although I haven't tried it. A more common scenario would be, for example, you've got CM users that have a 4-digit dial plan, and then calls get routed to the Session Manager, which converts to 5 digits and sends it off to a different part of your network. But yeah, that's the sort of thing that adaptation is for. So I think we have time for a few more questions here. Okay, I forgot to talk about how this relates to SBCs. So the question here is, I'm familiar with doing regex adaptations with ASBCE. What situations might be better to perform adaptations in SM instead of in SBCs? So the whole reason we implemented this feature is because we had a very large customer with a lot of money to spend complaining to us, you know, we modify SIP messages a lot. And we do it in the SBC because that's part of what SBCs are for. And man, figuring out the scripting language in the SBC, and I don't know whether they were talking about an Avaya SBC or somebody else's, but I think there's a problem with everybody's SBC. There's a proprietary scripting language. Each SBC has its own scripting language, and you know, you've got this gigantic book that describes the scripting language. So if you want to modify a SIP message in this way, you need to write a script that does this. So here you are in a text editor, you're creating your script. You don't really know whether the script works or not. You try it out, it doesn't work, and it's like, oh, okay, what went wrong? So the request from the customer was, can you give us the same sort of capability in Session Manager, but make it a lot easier to use? So what you'll discover is that, yeah, you can do the same sorts of things in the SBC, or you can do them in Session Manager. But the system manager forms that control regular expression adaptation, I mean, they're all GUI based. There's no scripting involved here. It's all drop-down menus. It's supposed to be very, very user-friendly. And then we've got the additional tools like the call routing test or the regex debugger that let you see the effects of the things you're doing without necessarily putting them into production. So is there a situation where, I mean, apart from the usability concern, is there a situation where it's better to do the adaptation in the Session Manager than the SBC? I don't know that there's really a situation where it's better. It totally depends on what you're trying to accomplish, I'd say. But is Session Manager adaptation more user-friendly than doing the same thing in the SBC? I would argue that absolutely, yes, it is more user-friendly. Let's take a few more questions here. So in a deployment that includes SIP trunks and an SBC, where should adaptations be? Same question, basically. Is it the same as the SBC Sigma scripting language? Well, no. Like I said, this is all GUI based. There's no scripting involved, which theoretically is going to make it much, much easier to use. Is there a tool to bulk import digit conversions? Yeah, there is in general a capability in System Manager to do bulk imports. There are a couple of different ways to do it. One is to import a spreadsheet. There is also a REST interface into System Manager. And I'm pretty sure digit adaptations are covered in that. So to the best of my knowledge, the answer there is yes. Is there a way to test the regex expressions as you write them? Well, we talked about the regex debugger. That would be the way to do it. And as far as deploying them against a SIP entity, you can actually administer them on the SIP entity, but make them test only, and then you can play around with the call routing test and see the effect of the regex adaptation without actually putting it into service. So I think we have time for 2 or 3 more here. Is there a REST interface for regex adaptation? I do not recall offhand whether System Manager implemented the REST interface. Like I say, I'm pretty sure there's a REST interface for digit adaptation. I'm not sure whether they've gotten to that for the regex adaptations, so I'll have to research that one. Why would we want to match against the third route header and change it? Well, the short answer is that was an interesting example. So the longer answer, why would you ever want to do that? You could imagine that you want to reroute the calls based on some sort of routing in your telecommunications network. You don't want to actually use the IP addresses that came to you. Instead, you want to modify those IP addresses in a subtle way. Maybe you want to change them from IPv4 to IPv6. I don't know. Again, the short answer is that was just an interesting example to show you the capabilities. And one last question. The call routing test only exists in 8.1.2. No, that is not correct. The call routing test has been around for a long, long time. The change in, I think it was 8.1.1 actually, the change in 8.1.1 is to expand the call routing test to make it more usable for regular expression adaptation. So the change there was you can insert arbitrary headers. And while we were tinkering with the call routing test, we also made the GUI a little more usable. So we're already 14 minutes over. We'll cut off the questions here. And again, I will take the time to answer as many of these questions as I can possibly answer in writing, and that'll be distributed to the participants, let's say in roughly a week. So that is all I have. Thank you for your attention. And back to you, Marlia.
Hey, thank you everyone for joining us, and thank you to Dennis from Avaya for taking the time to speak to us today. As a reminder, this webinar was recorded and will be available for on-demand viewing by the end of the day. You all will also get an email with a PDF of the slides to review. To see what webinars we do have coming up and to learn more about the IAUG webinar program, visit us at iaug.org/eventseducation/webcast. Please make sure to complete the short evaluation that will pop up as you exit the webinar and let us know how today's session went. I hope you all have a great rest of your day. Thank you, everyone.